we have the 2 digits, which in this case is 16. That means the primary port number. That means these 16 ports will be corresponding to the first 2 digits, the gigabit Ethernet and the PoE switch. That means in this model, it's got 16 ports of gigabit PoE ports, and after the 16, there will be the last digit will be the additional port number. So in this case, that's 4. That means we have 4 additional port number. And after the last digit, we will have another 2 letters just to represent, to explain the port type of the additional port number. So in this case, that we will say it's got 4 ports of a non-gigabit, 4 ports of a non-PoE gigabit Ethernet port. And of course, M12 means that all ports will be in M12 connectors. And we also have letters to explain the bypass function. We will have a BP1 or BP2, or some of the models that without the bypass function, we will not put the BP letters here. So this is in this case, it's BP2. That means it's 2 pair of bypass ports. And after that, in the end of the model name, we have a 24 volt. That means the power input type. And we have NB, HV, and also the 24 volt means that from the 12 to 57 volt DC power input. TPS 3162 GTM2 BP1. And this is the transport switch with totally 18 ports. And in these 18 ports, we will have 16 ports of a 1000 PoE ports and 2 ports of additional ports, which is running in gigabit Ethernet. And of course, in M2 connector and 1 pair bypass. For this model, we also have a 24 volt DC model. So you can the power inputs will be, for the standard model, will be 48 volt DC, and for the 24 volt model, the power input will be from 12 to 57 volt DC, and down here you can find out the PoE output power. For the standard model, 48 volt DC, the maximum power output will be 240, and from the 24 volt DC model, that you can see as well, there are 2 sections. From the power input from 12 to 24 volt DC is 120 watt, and from the 24 to 57 volt DC, the power output will be 240, same as the 48 volt DC power input. For this model, the PoE standard is AO2.3 AF and 15.4 watt per port for maximum. And we also got two pair of, as I mentioned, 2 pair of bypass ports, and this, and no, I mean that 1 pair of bypass ports and totally 2 ports. And it's on, as you can see from the product picture, is on the right hand side here, and it's on the additional 2 gigabit ports. And the working temperature from -40 to 75 degrees Celsius. Okay, so for another model, TPS 3882 GTM2 BP1. This model is pretty similar to the previous one, but the PoE ports will be only 8 ports. So it's 8 ports of it's as well. It's an 18 port managed PoE switch with 8 ports of 1000 PoE port and 8 ports of 1000 PoE port, and 2 ports of additional, which is a gigabit port, and it's as well non-PoE ports, and 12 connector and 1 pair bypass. For this model as well, we have a 24 volt DC model. The power output for the standard model is 120 compared to AO2.2 AF, 15.4 watt per port, and times A will be 120. And for the 24 volt DC model, there are as well 2 sections. For the power inputs from 12 to 24, 60 watt, and from 24 to 57 is 120. Operation temperature is from 40 to 75. So this is as well a comparison table for the reference that we have totally 18 ports and more than the multi freshman. We have 16 ports of 1000 PoE ports, 1 petabyte paths, and PoE ports we have 16. So this one thing I want to mention too is that for most time for Hirschman or maybe for other companies, PoE switch, mostly I can find out is that they only have 8 ports of PoE ports, mostly. And for ORing products, now we have 16 ports of L2.3F, and this is one of the points that maybe you can pay more attention to this. And for the selling points, or let's say the advantage here, we have the high port density. So for both 3162 and for 3882, and for it's also the total port number will be 18, and we have 16 plus 2 and 8 plus 8 plus 2. So the port density is higher. So and also the 2 gigabit Ethernet that you can use for the backbone purpose, and the other 16 ports that you can use in-train entertainment or some of the railway Ethernet connections. TGPS 9084 and 1252 is a more advanced model comparing to the previous two ones. That for this model is 12 port of managed gigabit PoE Ethernet switch. So for the previous two models, it's mostly 1000 Ethernet ports, and for this one, it's TGPS 9084. That means the all 12 ports are gigabit Ethernet, and so we have 8 ports of gigabit PoE ports and compared to the L2.3AT. So that means that each port can provide up to 30 watt per port, and the total power output will be 240. And we have 4 additional ports running gigabit Ethernet with non-PoE ports, and 2 petabyte paths on the additional ports. Okay, for TGPS 9084, we also got a 24 volt DC model, as you can see here. The power input is from 12 to 57 volt DC, and the power output will be as well 2 sections. From the 12 to 24 volt DC, the power output will be 60 watts, and from 24 to 57 volt DC, the power output will be 120. And the others will be mostly the same as the standard ones. So the L2.38, L2.3AT standard for the PoE, and then 2 petabyte paths. So the reason why I show the dimension here is because mostly in ORing's transport service products, that the bypass ports, or let's say the additional ports, will be placed and installed on the right hand side. For this model, TGPS 9084, and for the maybe next model, TGPS 9164, the additional port and the bypass function will be placed on the left hand side, as you can see from the dimension, the front view. TGPS 9164 3D and 1252 is pretty much the same as the previous model, but we have more Ethernet ports here. So for this model, the total port numbers will be 20. So it's a 20 port of managed gigabit PoE Ethernet switch with 16 ports of gigabit Ethernet and PoE functions, and also 4 additional ports of non-PoE function as well gigabit Ethernet interconnector to the paths. And the power inputs for this standard model, so it's 50 to 57 volt DC. So here you can see from the power output, I think this is another thing that you can, I would like to mention that we have 16 ports running PoE and L2.38 standard, each 30, and that means 30 watt per port maximum. So the total power output here will be 480 watts, and I think that's some of the other companies' products that they don't have that much of a power output. And others will be pretty much the same, 2 petabyte paths, and the operating temperature from maybe 40 to 75. TGPS 164 GTM32 also got a 24 volt DC model. For this model, it's got so you can see here the power input from 12 to 57 volt DC, and another two sections, 120 watts for 12 to 24, and 240 watts for 24 to 57 volt DC. The others will be the same as the previous model, and for all of our transport service reference switch, we will have the EN 50155 certification test. So another dimension for you just for your reference. The advantage of the TGPS 9084 and TGPS 9164 against high port density, which is 20 ports and 12 ports, and which is running all of the ports are running in Gigabit Ethernet connection. So for these two models, that it's mostly you can use in some of the in-train entertainment system or some of the in-train IP surveillance that requires high resolution application, and the bandwidth will be higher. Will be higher bandwidth requirement. You can use the two models here. So for application that is in-train IP surveillance, passenger entertainment system, and railway Ethernet connections. The component table is for your reference, and you can maybe later you can check it. IDS M311 is a one-port mobile gateway with one port of RS-232, 422, and 485 to one port of 1000 Ethernet. And the operation mode will be RTU master, RTU slave, ASCII, master, ASCII slave. And the operation mode will be explained in later pages. The power input is from 12 to 48 volt DC. And for the mobile gateway application, maybe some of you have already know that before the PC sending the mobile query or mobile command, that the PC needs to first establish the TCP connection with the mobile gateway. So for our mobile gateway, the maximum TCP connection allowed is 16 TCP connections allowed for this model. For the mobile gateway, the main function for mobile gateway is to convert the mobile protocols convert the protocols from mobile TCP to mobile RTU, or mobile TCP to mobile ASCII, or let's say the Ethernet interface to the serial interface. So the mobile gateway can convert two things. The first is the interface, and second thing is the protocol. IDS M311, there are 4 operation modes, as I mentioned, and there are another 2 parameters that I would like to talk about here. The first is serial addition rate. That means after each time when in some of very old serial devices, that after receiving the query and the serial device will send back a feedback to the mobile gateway. And for some of the very old serial devices, that after reply the feedback, the device might need some time to get back. Let's say to get back to ready status and in order to receive the next command. In this case, that you can set the serial addition wait time for the mobile gateway after the gateway send out the query or receive a feedback, that the mobile gateway will wait for a certain period of time, then send the second query. And for the connection timeout, we can also call it idle timeout. As I mentioned here, that for our mobile gateway, the maximum TCP connection allowed here will be 16 TCP connection. So usually that when the PC sends out the query and to the mobile gateway, or let's say usually when the PC finish the data reading section, usually the PC will also send out the termination request for the mobile gateway to disconnect the TCP connection. But in some of the cases that either it's software or either it's computer or either any reason that the TCP connection is not terminated. That in this case, mobile gateway here, IDS-M201 will need to use this kind of parameter to disconnect the TCP connection in order to release the resource, the TCP connection resource here. Okay, so in here is a picture that pretty much explains the different operation modes, the difference between different operation modes that as you can see, we have the RTU master, RTU slave, and ASCII master and ASCII slave. The biggest difference between the slave mode and the master mode is which side sends out the mobile query. So in slave mode, this is also the mostly used mode here. So the PC, or let's say the mobile query, the mobile master device will be placed on the Ethernet side and running the mobile TCP protocol, send out the query to the mobile gateway, and the mobile gateway will convert the query to the mobile RTU or mobile ASCII protocol and to send out to the serial slave devices. But in some other cases that the mobile master device will be connected to the RS-232 and using the mobile RTU protocols. So in this case, we will have to use the RTU master mode that mobile gateway will have to convert the mobile RTU command to the mobile TCP protocol and send out to the mobile TCP slave devices. And here is a little comparison with mobile gateway and the device server that maybe some of you might be confused. So for the device server, the device server is running a protocol which is called the Virtual protocol, and for the mobile gateway, of course, it's mobile protocol. And in the communication section, device server is actually transparent. That means we will not change, the device server will not change the data format, and will just transparent bypass the data to the serial devices. But for the mobile gateway, there will be a protocol conversion. So we will change the data format from either mobile TCP to mobile RTU, or from mobile RTU to mobile TCP. So conversion table for your reference. For our wireless products, we have as you can see, the main visual for your reference that we have three means that get Ethernet and AP or AR for different types of wireless products like access point or cellular router. And for some of the models, we have a waterproof. That means we will have a W in front of before the model name. And so in IP67 degree and IP67 grade. And the first digit will be the cellular module, the number of cellular module, and the second and third data will be the Wi-Fi module number, the Wi-Fi module type, and the last digit will be the Ethernet port number. We will also have a plus or non-plus for represents for the PoE model or non-PoE model, and 4G and 3G, that's easily understand. That means which type of cellular module we are using here for this model. TGAP W6610 plus M12. This is a transport series, access point with waterproof IP67 grade, and there are two Wi-Fi modules with the IEEE 802.11 ABGN, and also got PoE PD function, so you can easily power up this device with a PoE function, and it's in interconnectors. And for this, for all of our access point or cellular router, the operation mode will be AP mode, client mode, bridge mode, and AP client mode. The maximum SSID here, we can provide up to 4 multiple SSID, and will be explained how this function can be used here. TGAR W1061. 4G and 12. And this is a transport service access router with IP67 waterproof grade and has in the EM50155 certification, and this one serial module with 4G, and we also got a 3G model here, but it's here, but we can pretty much the same as the 4G model, just change the serial module, and also got one Wi-Fi module of IEEE 802.11 APGN, and it's a 4G model and 12 connector. The hardware specification of the previous two models, as you can see, mostly have the two models have one port of Gigabit Ethernet and two Wi-Fi module and one serial module for the AR model, and we all have a PoE standard applied to the 802.380 PoE standard, and the Wi-Fi module will be 802.11 APGN. So the compression table, I think, is maybe you can check it later after we send the slides. Just for your reference, that maybe if there's any customer asking for replacement. Okay, for IAP 420 Plus, this is a really compact size, a small size of access point with one Wi-Fi module of 802.11 EGN and two ports of Ethernet ports. And this model also got a PoE model. So one of the ports will be supporting the PoE PD. So for this model as well, support the operation mode of AP mode, client mode, bridge mode, and the AP client mode. The hardware spec of IAP 420 is support the roaming less than 100 milliseconds handover time, and for some of the security for WEP, the VA, and so support the maximum SSID supported here will be 4. IAR 142 Plus 3G is the access is a cellular router device of one cellular module and one RF module, support 802.11 BGN, and as well we have a PoE model here, and it's, right now we only have a 3G model for this one. And as well, this model is really small size here, so that in some of the places or some of the application, some of the project that requires really small size for access point or router device, that you can choose to use these two models. IAR 142 3G, and as you can see here, we have the RF module supports the 3.5G HTTPA connection, and some of the router functions here we have support NAT settings, the DMZ, or some of the virtual server functions here. Okay, for the multiple SSID here, the reason why we use this we will need this kind of function is that it's for security purpose, and how this works is pretty much like a VLAN function. So we can separate different groups, like we can have a group A, group B, group C, and group D connected to different SSID, and also all of these groups can be set up to be separate from each other. So in this case, that means group A will not be able to access group B, so that this is one for security purpose, and another one is for EZD management purpose. INJ 102 GT++, 24 volt, is an injector and of maximum totally 4 Ethernet ports, as you can see from the picture, and two of the ports will be data in, and two of the ports will be PoE out. And I will explain how this injector works later. So for this injector, it's compliant to both L2.380 and L2.3F. And the maximum power output of the injector will be 90 watts in total. So the power input of this model, for the 24-volt model, will be from 24 volt to 50 volt. But for standard, will be 50 volt DC power input for standard model. Okay, for how injector works is that we can integrate, or we can, let's say, combine the power supply and the data in from another Ethernet switch, and we can combine the two source and to send out from the PoE out port here, so that any devices connected to the PoE out port can receive both power and the data. As maybe you can see here from the picture that we have a totally 4 ports. That means that we have a 2 pair of data in and the PoE out, and they can work together. But the maximum power output as well is still 90 watt. Either you use 1 pair or you use only 1 pair. That means 1 pair or 2 pair. That the maximum will be 90 watt power output. Okay, the comparison for your reference. The DBU01 is a data backup unit, and we have different 3 types of connectors. We have RJ45, N12 connector, and DB9 connector, depending on the which type of device you need to do the configuration backup. So we can, because we have different devices with RJ45 connector and N12 connector and DB9 connectors. For this DBU01 data backup unit, we can mostly store two types of configuration, and we can you can easily do the upload and download by the deep switch. So dimension is it's very small and really light. The weight is less than 50 grams. There's no power supply needed here. For the for ORing's products, which now you can see here, we have different series of ORing's products support the data backup unit. We have 9000 series of Ethernet switch and 9000 series of transport series Ethernet switch, and the access point is the little routers, which all support the backup unit. And the compression table as well for your reference.
Thanks, Peter Guo, for detailed introduction on our latest products. Now we have 2 questions. You may answer the questions by typing your answer into the question box. Do you see the question box? It is in the downside of the GoToWebinar panel. And don't worry that others cannot see your answers, so it's okay to guess. The first question is, what's the maximum power output of injector 102 GT plus 20 volts? You can key in your answers into the question box. Well, the answer is 90 watts. Okay, congratulations to Pat. You can get our small gifts. Okay, and the next question is, please list out the 4 operation modes of IDS M311. Okay, anyone has answers? Wow, great. There are 3 people. Let's Minami and Ted. The answer is R2 master, R2 steps, ASCII master, and ASCII steps. Okay, and we'll send you the gifts later on. Okay, that's all for the first section. Next, our senior product manager, Bruce Zhang, will introduce MIMO technology. Let's welcome our speaker, Bruce.
Good day, everyone. I'm Bruce. Today we will talk about the concept of MIMO technology. I believe most of you ever heard about it, but probably don't have completely idea of this MIMO technology for wireless communication. Okay, sorry. Why do we need to use MIMO technology? Nowadays, the wireless communication completely changed our living style. We use cellular phone, wireless data communication by mobile devices like laptop or tablet, etc. New wireless communication technology are developed from these applications. Developed for these applications. For example, like 3G, LTE, which is a stand for long-term evolution, WiMAX. These technologies are used for mobile application, and IEEE 802.11n and IEEE 802.11ac for Wi-Fi application. Therefore, the requirement with a higher data rate and a better signal quality of wireless communication become more and more important today. But as you know, the coding rates and data capacity versus bandwidth are mature today, and we don't have too much room to improve. But the demand of high speed wireless data communication increased rapidly, and we need to find solutions to fulfill the needs. So researchers spend all their lives to develop and research new technologies to improve it, and it won't stop. A new technology for wireless communication called MIMO are common use in these years. So what is MIMO? MIMO is stand for multiple input and multiple output, which is the technology to utilize multiple antenna for transmitters and receivers to construct multiple spatial streaming, just like multiple communication channels to get higher data rates. But how to achieve that? We may need to start from the essential concept of wireless communication. Basically, there must be a transmitter and receiver to establish the wireless communication. Traditionally, it's one-to-one communication, which is also called SISO, S-I-S-O, which is stand for single input and a single output. So one side is the transmitter and the other side is the receiver. Theoretically, they should communicate with each other perfectly. But in the real world, it's not possible to have this kind of ideal environment. There are so many interference, noises, multipass effects that weaken the wireless signal strength. The multipass effect caused by reflection from objects then result in multiple signals and arrive to receiver at different time due to different transmission distance. Therefore, it also called the delay spread. The multipass effect is varied with the environment. For example, at home it's less than 50 nanoseconds. In the office is around 100 nanoseconds. The factory is 200 to 300 nanoseconds, and less than 10 microseconds in downtown. But the question is how to against them. To get better signal quality, the technology used on the receiver side is antenna diversity. We just do it by increasing the number of receivers. This picture shows how it works. For example, there is one transmitter and two receivers. Both of the two receivers can receive a signal from the transmitter. What receiver needs to do is to measure the signal quality and make a decision which receiver should provide the final wireless signal. The decision is not always get the same, but change rapidly. This technology plays an important role in MIMO communication and measurement of wireless signal strength. Not only get better signal quality, but also help to beamforming technology to double the data rates. We will talk about it later. Another important technology on the transmitter side is the OFDM, which stands for orthogonal frequency division multiplexing. We didn't do the modulation with a single carrier frequency like the SSS, but in another way. Before the data sent out from the transmitter, we divide the data into several subgroup parallel data and use several narrow band subcarrier frequencies to carry those data. Just like this. And you can see the total bandwidth over here. So why do we need to use complicated OFDM methodology instead of simple single carrier frequency? This is because in the real world, a lot of interference or noises existed on frequency domain. So wireless signal will be interfered seriously like this, and the data will be corrupted. Of course, we can increase the signal to noise ratio, SNR, by rising up the transmitting power to get better signal quality. As you can see, the gray part is the noise, and the pink part is the transmit power, and the yellow part is the effective data. But we cannot rising up the transmitting power without limitation. This will cause another problem of radio interference. Please see the slide. Or we can just reduce the data rate by changing the coding rate. We'll talk about coding rate later. But but is there any other way to get better data rate but not rising up the power? Yes, the OFDM is developed for this demand. With this OFDM methodology, we can assign different amount of data on each subcarrier frequencies according to the signal-to-noise ratio management. The interference or noises measurement are proceeded continuously. Therefore, this assignment of data allocation will be changed dynamically. This is why the data rate of wireless connection may be varied with time. So in this slide is the simple concept of how we use different modulation at different coding rates. From the pictures, you can see several modulation methodology. For example, 16 QAM with 16 different symbols. Therefore, each symbol can represent 4 bits. From 0000 to 1111, it's in binary. Then a symbol of 64 QAM can represent 6 bits for each symbol. The modulation for lower data rates with higher tolerance against noise interference. For higher data rates, you can see the distance between neighbor symbols is much more closer than the lower data rates. Then interference will easily cause the detection error. That is the data error. Therefore, the receiver needs to detect the communication channel to come out suitable coding rate with minimal detection error. So as long as the communication channel is clean enough, or the distance of the transmitter and the receiver is close enough, that is, we have higher signal-to-noise ratio, then we can have better signal quality and a higher data rate. Now, we already have solution on getting better signal quality, but how do we get higher data rates? The basic concept is to apply more communication connections. This sounds good. This sounds simple, but actually it's difficult. We can allocate more bandwidth for wireless communication, but the bandwidth resources are limited. Or we can use more transmitters or receivers to get higher data rates. But if more than one transmitters transmit signals at the same time, it will cause a serious interference with each other. So the new technologies to make it possible are the spatial multiplexing and the beamforming. Spatial multiplexing is to obtain more communication channel Beamforming is to adjust the direction of electromagnetic field to get better signal quality. How do these methodologies develop? The idea is from the disadvantage of the communication channel effect in the real world, multipass effect, which is also called the delay spread, we just mentioned. This gives us an idea. Please see the slide as an example for the mechanism of beamforming. There are two transmitters and one receiver. The signal strength on the receiver is not in the best direction in the beginning. The receiver will measure the signal quality and feedback to transmitter to change the amplitude and the phase of the transmitted signal. Then the signal strength on the location of receiver will be maximized. This gives receiver better signal quality. This mechanism, just like the transmitter, can adjust the direction of electromagnetic field. Okay, with beamforming technology, the transmitters and receivers will find the best path and communicate with each other as a pair with minimal interference. MIMO is doing this way to build more communication channels. Also can say spatial streaming. Please notice the term spatial streaming. All those data streaming use the same frequency and the same bandwidth. Therefore, the data rate increased without extra bandwidth. This is exactly what we expected. Okay, this is the last slide. You can see many Wi-Fi devices in the market which market in 2x2 or 2x3 or 3x3 wireless connection. They are talking about the numbers of transmitters and the receivers respectively. They are always MIMO technology. Please see the table regarding to the data rates. There are so many parameters. First is the bandwidth. Of course, the data rate will be higher with more available bandwidth. The options are 20, 40, and 80, and 160 megahertz. The second parameter is the SGI, which stands for short guard interval. We've introduced the OFDM with guard interval to against the multipass effect. Normal guard interval is 800 nanoseconds. Short guard interval is 400 nanoseconds. If short guard interval is enabled, the data rate can be increased about 11%. The third parameter is the coding rate. As we mentioned earlier, it's depending on the signal strength and the interference in the communication environment. It's also related to the data rate directly. The last one is the key parameter, which shows the number of spatial streaming we introduced. It is highly related and dominates the data rate directly. Okay, that's the introduction of MIMO technology, and I hope it gives some basic ideas about wireless communication to you today. Thank you.
Okay, thanks for Bruce's interesting and informative introduction. It's our quiz time again, and the first question is, what is the term to represent the number of wireless communication channel of MIMO technology? If you know the answer, please write down the answer in the question box. There's hint. There are two words. Okay, the answer is spatial streaming. Sorry that nobody answered the question in this part. Okay, and next, let's welcome our quality engineer, Jerry, to introduce you their 3 feature.
Hello everyone, I'm Jerry. Welcome to join our ORing online webinar. Thank you all for being here. Today, I would like to talk to you about what are Layer 3 features and why we need Layer 3 features. The main point I will talking about are those 5 points. Firstly, what's different between layer 2 and layer 3 feature? Secondly, what is routing? Then I will introduce RIP, VRRP, and bypass features. So let's go into look at first topic. What is layer 3 feature? In the 7-layer OSI module of computer networking, the network layer is called layer 3. The network layer is responsible for packet forwarding, including routing through intermediate routers. What's different between layer 2 and layer 3? The first different point. We all know layer 2 packet transmit by using MAC address. For example, MAC address 01 transmit to MAC address 02. But if we try to transmit layer 3 packet, it must use using IP address. For example, IP address 192.168.1.1 transmit to 0.2. The second different point is layer 2 packet not allowed to cross different subnets. You can see this picture. It cannot transmit packet between subnet 0.1 and 0.5. But if you're using layer 3 switch, it allows packet to cross different subnets by routing. That's why subnet 1 can connect it to subnet 0.5. You may ask me, what is routing? Routing is the process of selecting best path in a network. There are 2 kinds of routing, static routing and dynamic routing. What is static routing? Static routing means the routing table updating by manually setting and cannot learn in new routing information automatically. Here is an example. Here is an example. Routing table already created in each routers. Now if you try to transmit packet from host A to host B, the first thing is check out the routing table. You can see there has subnet 192.168.1.0 in routing table, and it matches subnet of host B. So packet can transmit from A to B by routing. Example 2. If the routing information does not exist in routing table of switch 2, switch 2 will ask all of his neighbors who has the destination information. But no one has that information. So packet cannot transmit from host A to host B. Now let's move on to dynamic routing. Routing table updating by dynamic learning is called dynamic routing. For example, if you try to transmit packet from host A to host B while dynamic routing disabled, you can see there are some routing information already exists in switch 1 and switch 2 routing table. Because there are no host B information in switch 2, so transmission will fail. To fix this problem, we can enable dynamic routing protocol such as RIP. The same situation as before. There are no host B information in switch 2 routing table. But now switches will transmit RIP packet to each other to update their routing info. So host A can transmit packet to host B by routing. Then what is RIP? RIP, Routing Information Protocol, is one of the distance vector routing protocols. RIP selecting best path by using hop count and transmit update packet every 30 seconds. RIP maximum hop count is 15. This picture shows how RIP working. There are 6 switches between A and B. Now let us choosing which is the best path for A to B. RIP will selecting the best path by calculating hop count. So we just count switch 1 as hop count 0 because it's the first switch we pass. Then count switch 6 as hop count 1. Now we have to make choice. The next node should be switch 2 or switch 5. So we are using RIP protocol now. In this picture, you can see the orange nodes are less than green nodes. So the orange nodes should be the best path by RIP. So we should choose switch 5 for the next node. If we are using the other routing protocol, such as OSPF, it will choose best path by using speed and cost. But now we don't want to discuss OSPF now, so just pass it. Next topic is VRRP. VRRP, the Virtual Router Redundancy Protocol, is a computer networking protocol that provides for automatic assignment of available IP routers to participating hosts. This increases the availability and reliability of routing path by automatic default gateway selecting on an IP subnet. I can make it be simpler. Let's take a look to next picture. You can see this is the situation that without VRRP, client and server setting gateway to real IP and connected by switch A. But if switch A has something wrong, such as power off or cable link down, client cannot connect it to server anymore. It's a very serious problem. Then here is the solution. We can use VRRP to avoid this situation. By using VRRP protocol, we set gateway to virtual IP on both server and client. Server and client connected by switch A and switch B, or even more. Switches between server and client will choose one major switch to transmit packet and choose the other one as backup switch. Let's take a look to this picture. If the same situation is happening, the major switch will change from A to B, so the connection will not affect. That's why we need VRRP. The next topic is bypass feature. Bypass feature is working on a hardware device that provides a fail-safe access port for an inline monitoring appliance. It can protect the network from failure and subsequent maintenance by ensuring networking integrity during power loss. You can see there is a huge network and switch connected to switch one by one. So if one of those switches was down or something wrong, the whole network will be broken and not working. But if switch B supported bypass feature, it can still transmit packet. You can imagine that switch B did not exist and switch A connected to switch C directly. So it's time to make the conclusion. You can get layer 3 feature by using our product IGS R9812GP and IGPS R9084GP. And you can get bypass feature by using our product TGS R9812GP IAO S series. Thanks.
Okay, thanks Jerry for his detailed information on layer 3 feature and bypass. Okay, it's quiz time again. And the first question is static routing updating routing table by manually setting and dynamic routing by dynamic learning. So which one is suitable for huge network? Please answer in the question box. Okay. The answer is dynamic routing. Okay, then all these sections are finished. Do you have any questions? If you do, please raise your hand, but don't really raise your hand. You can see a button on the left side of the GoToWebinar panel that's showing raising your hand. So you can just click the button to let me know. Or you can just leave a message if there's any question. Okay. If there's no further questions, that ORing on a webinar for Asia and Pacific area is coming to an end. And thanks for your attendance. If you are interested in our latest products or getting more information about our latest technology, please feel free to contact ORing account sales. We will send you today's presentation file for your reference. ORing seminar, we will see you next quarter. Thank you and goodbye.